purpose of this video is to walk you through a problem on sinusoidal modeling. I assume that you've downloaded the Stork journey and are able to look at the problem in front of you, and that you have read the problem and are familiar with the specifications of our Stork slide. So we're going to start here and answer the first question. We want to draw the sketch, but before we can do that, we have to write the equation. And before we can write the equation, we have to extract all the important information out of the problem itself. Now, obviously, this problem is made up, but as you work on the problems that are assigned, you will see that they do have real-life applications. So reading through the problem, we see that our max is 11, our minimum is 3, and from that, we can find the sinusoidal axis of 7. You just add the max and the min and divide by 2. Once you find the axis, you can calculate the amplitude by just looking at, well, if you start at 7, and you go up to a max of 11 and down to a min of 3, your amplitude has to be 4. The period is given as 13 minutes because that's how long it takes the stork to complete his journey. And that leads us to an important conclusion. I'm going to call it B, and I'll tell you where that comes from in just a minute. B is 2 pi over 13. So you know if you're given an equation, you can find the period by taking 2 pi divided by that number in the equation. If you're given the period, you can work backward. So the equation that I'm operating with here is y equals a sine of b x minus c plus c. And you'll see different variations of this equation depending on where you look, depending on what textbook you use, depending on what video you watch. I've always just used A, B, C, and D because they're easy for me to remember. So notice that B is factored out from the rest of the quantity, and really that's so that we can see the phase shift. So just to review what these letters all mean. A gives us the amplitude, B helps us find the period, C gives you the phase shift as long as the B is factored out, and then the D is the vertical shift. So a lot of these things are falling into place just by extracting our given information. There is no phase shift in this particular problem as long as we go with the assumption that we are using the sine curve. So we can go ahead and write the equation for our height. We know that h of t, this is just function notation, is equal to 4 sine 2 pi over 13 t plus 9. So now that we have our equation, we can go ahead and construct our graph. So I have the graph laid out here, and I've included enough tick marks on the t-axis to graph 2 full cycles. So our first cycle is going to end at 13. And the reason I have 4 tick marks for this first cycle is because the unit circle is divided into 2 spots, or four areas. And that's kind of how we're breaking apart this graph. To find the other tick marks, you can simply use the midpoint formula. So 0 plus 13 divided by 2, 0 plus 6.5 divided by 2. Or once you figure out that you're going up by 3.25, you can just obviously continue to add that. I'm going to fill out the rest of the scale. And again, I'm just going to incorporate 2 cycles. If you just draw 1 cycle, that would also be sufficient. And our time is measured in minutes. On the y-axis, we're just going to go up by 1 to our maximum height of 11. And our height was measured in kilometers. So the first thing that I do when I graph a trig function is I draw the sinusoidal axis. It's not really a part of the graph, but it's definitely a helpful tool in sketching the graph. So at 0, we are starting at 7. And because we're using a sine curve, at our first tick mark, we're going to go up to a max, and then back to a 0, down to the min, and then back to where we started. And to graph 1 more cycle, you're obviously just going to repeat that process. So try and make a nice smooth curve here. And you will see that we have 2 cycles of our Stork's journey. The next question asks us how high is the stork at 25 minutes? Well, that's another good reason I have 2 cycles in here. So 25 minutes is right before the end of our second cycle. So we'd expect him to be a little bit below 7. We can calculate that exactly, though, by just plugging in 25 into our h equation. So what you need to realize if you're going to put this in your calculator is that you are operating in radians And all we're doing is replacing the t with a 25. So also keep track of your parentheses. If you plug this in, you will find out that the Stork is approximately 5.14 kilometers when the time is at 25. And again, remember, you have to have your calculator in radian mode. The last question is a little trickier. It is asking us to find the time when the Stork is at a height of 9 kilometers. We have not learned how to solve trig equations yet. That doesn't mean we can't answer this question. Let's go back and look at the graph. And we can estimate when the height is at 9. So right about here, 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 and here. So it's going to be 2 times every cycle where the Stork is at 9, which makes sense because of the unit circle. There's definite symmetry there. But we don't want to just estimate. We want to give the exact answers. So to do that, what you want to do is grab your calculator. Again, verifying that you're in radian mode. Go to your y equals screen and type in your equation. Obviously, we'll have to change the h's and the t's to y's and x's. Then set up your window so that it looks exactly like the window that we have drawn by hand. And then when you press graph, you should get a picture that looks exactly like we drawn by hand. Now we're interested in finding out when the Stork is at 9. So what we're going to do is in y2, we're going to plug in 9. And we're going to take a look at that graph. Whoops, the graph, not the signal. There we go. And you can see that we have the 4 intersection points just like we marked on our graph. And now we want to find those intersection points. So to do that, we're going to go to second calc, and we're going to arrow down or press 5. We'll get us there faster. To intersect. And you have to kind of tell the calculator where to look. So the first curve, just hit enter because we're looking for just verifying which curves we're using. So we're looking at the sine curve and the straight line. And then it says our guess. So here's where I actually want to move the cursor over to my first intersection point. Because there's quite a few intersections here, so we're going to guess right there. Hit enter. And we have our first intersection point. So at 1.08 would be the time. Arrow over to the next one. And actually press second calc again, and we'll do intersection. And it says first curve, yes, I want the sine curve. Second curve, yes, I want the line. And then it's going to again ask us for our guess. So we're going to guess over here. Press enter. And you'll find out that we have 5.41. So going back to our question, we can definitely answer this one. And we can say that the time was approximately 1.08. That would be time 1. And that the second time that the Stork hits 9 would be at 5.41. But those do not incorporate all of our intersection points. As you notice from our graph, we hit them again and then again. But the Stork's journey took 13 minutes. So exactly one cycle or one revolution around the unit circle, if you will, if you were thinking in terms of pies and 2 pies. So in order to incorporate all of the time, we're going to add multiples of 13. We just use the letter K to represent a constant. So on the way up, the Stork is going to hit 9 at 1.08 minutes, and then every 13 minutes after that. And then on the way down from the maximum height, you would hit 9 kilometers at 5.41 minutes, and then every 13 minutes after that. So this concludes our Stork's journey. If you have any questions, please come during resource. And your assignment is to pick out 2 of the sinusoidal modeling problems and turn those in for a grade.